Hello there. Electric circuits exist in every electronic device, from phones to satellites, from a simple bulb to a complex robot. So, in this lesson, we will introduce the concept of an electric circuit. An electric circuit represents the path through which an electric current moves from the source of the current through other devices before re-entering the source. To illustrate, we will use a simple circuit consisting of a source, for example, a battery, connected using a conductor like a wire, going to a load such as a bulb, and finally, a switch, which is also known as the key. The key serves to open or close the circuit. This obviously implies that there are two types of electric circuit: the open circuit and the closed circuit. An open circuit is one where there's a gap in the conducting path, meaning that the key is open and the current cannot flow through the whole system. Because there is no flow, we can see that the bulb stays off. A closed circuit, on the other hand, is one where there's no gap in the conducting path, and current flows through the entire system, lighting up our bulb. There is a special type of closed circuit known as the short circuit. This is a closed circuit in which there is no load. That is to say, the current does no work. Now that we have introduced ourselves to the concept of electric circuits using a simple circuit, let us learn a bit more about some other components that we can use in a circuit. Let us start with the ammeter. The ammeter is an instrument used to measure the flow of current. The unit of measuring current is in amperes. Next is what is known as the resistor. The resistor is a component that restricts the flow of current in a circuit. And the measure of this opposition to the flow of current is what is known as resistance. The SI unit of resistance is the ohms, represented by the Greek omega symbol. Resistors can either have a known or a variable resistance. A standard resistor provides a constant amount of resistance in a circuit. It is usually made of a specific length of resistant material with a fixed resistance value. For instance, a standard resistor of 3 ohms will always provide a resistance of 3 ohms when it's connected to any circuit. The variable resistor is a component whose resistance can be increased or decreased. The most common example of this is called a rheostat. It varies its resistance by changing the length of the resistant wire. Another component which we could have is the capacitor, which stores electrical energy in the form of charges. This was introduced in our previous lesson on electrostatics. How about another? The fuse is a safety device that opens the circuit when current exceeds a certain amount. Consider it an automatic switch that is activated to cut off the current flow when the current is too high. And finally, let's talk about the voltmeter. The voltmeter measures the potential difference across 2 points in the circuit. Note, when all these components are connected end to end, it is known as a series connection. But as you can see, the voltmeter is connected differently. It is placed side by side with the circuit such that the corresponding ends of the component meet the rest of the circuit at 2 junctions, as shown. This is known as a parallel connection. Wow! These are just some of the most basic components that can be used in a circuit and their functions. Take a moment to look through the circuit and see which ones you can identify. How did you do? Let's go through them again. There's the source, the conductor, the resistor, the capacitor. Over here we have the variable resistor and the fuse and an ammeter. And finally we have the voltmeter and the switch. Easy as 1, 2, 3. Go through these and you'll be on your way to understanding electrical circuits in no time. We've now come to the end of our introduction to electric circuits. See you next time.